Liking this video will help this channel to grow. So please go ahead and give this video a like. On the back of the two previous sections covered in this lesson, today we'll be looking at expanding triple brackets. Feel free to engage with the practice questions provided in the description of this video, and as always, remember to like, comment, and share. Guys, as we wrap up this lesson on expanding binomials and polynomials, let us look at what happens when we expand a triple bracket. When we expand triple brackets with the same algebraic term or the same terms, the result is called a cubic expression. Very important to note what is the definition for a cubic expression. Now, a cubic expression is an expression whose largest exponent or power is a cube. Now, you should have watched part 2 of this lesson, where you would have seen us expand double brackets, and we talked about the fact that once we expand double brackets, the highest power would be a square, hence the expression is called a quadratic. Now, because we're expanding 3 brackets, now the highest power is going to be a cube, so it's called a cubic expression. Now, these terms must only have polynomial terms. In the last lesson also, we talked about what a polynomial was, so you can have a look at that if you haven't yet seen it. So here is an example of what our cubic expression will look like. So it will basically have 4 terms. A cubic term, which is the highest power, you can see that here, x cubed, so the highest power is 3. That's our first term. The second term will be a term that has a power of 2, which is the quadratic part of the cubic part, and you'll see where that comes in the example. Then we have a third term in terms of x, and then a constant term, which will always be a number. Absolutely brilliant. So 4 parts to this cubic expression. Now, how do we expand triple brackets? Now, to expand 3 brackets, we follow the steps below. So again, watching video 1, video 2, you would be more prepared to do your triple bracket as well. So the first part here, we multiply the first term in each of the 2 first pairs of brackets. So we're multiplying all the terms in the first by the second, just like we did when we were expanding 2 brackets. So once we've done that, we're going to list all the terms, collect our like terms, but the only difference here with the quadratic and the cubic is that when we get the quadratic part, we would now use the third bracket to expand that quadratic bit. So it's just one more step, expanding 2, and then using the answer from those 2, we're going to now use the third bracket to expand those. And again, we will collect and simplify by collecting the like term. So you've got all the basic skills from watching video 1 and 2. We're just going to simply put them together. Absolutely brilliant. So now we go to our first example, where all terms in each of our binomials are positive. So all is positive. So we've got 3 brackets here, x add 4, x add 8, and x add 3, and we're asked to expand and simplify. So what we're going to do, we're going to use the FOIL method. So we're going to expand the first 2. So it's x add 4 and x add 8. And then when we collect the result and use it to multiply the third. So let's go. So x times x here gives us x squared. X times by 8 gives us 8x. 4 times by x gives us 4x. And 4 times by 8 is 32. Beautiful. So now we need to simplify by collecting the like terms. For the b term here, we get x squared plus 8 add 4 is 12, so 8x add 4x is 12x, and our constant is 32. So you can see here we got the first part to be a quadratic. Now we're going to use this quadratic and use it to expand the third bracket. I always like to put my third bracket first so I can use each of those. It's just 2 to be distributed to the other bracket rather than the other way around. So let's go. So rewriting that, I'm just going to use x times by x squared gives me x cubed. X times by 12x gives me 12x squared. And then x times by 32 gives me 32x. Beautiful. So I'm finished using my x term. I'm now going to use the 3 here. So 3 times by x squared is 3x squared. 3 times by 12x, just going to carry on in the second line here. 3 times 12 is 36, so that gets me 36x. And then I need to do 3 times by 32. So 3 times by the 2 is 6. And then 3 times by 3 is 9. So 32 times by 3 is 96. All I need to do now is to collect my like terms. So I know my cube term stands out by itself. So I've got x cubed, nothing to add to that. But I've got my x squares. So 12x squared is a like term with 3x squared. So 12 and 3, that's 15. So I get 15x squared for my x squared term. Now I need to add my x terms together. So I'm going to put 3 lines under this one. I've got 36x and 32x. So I need to add 36 and 32, which is 68. So 68x. And then my constant is positive 96. Now I need to check because we've discussed that my cubic expression has to have 4 parts. So I've got my x cubed, I've got my x squared, which is 15x squared, I've got my x term, which is 68, and I've got my constant, which is 96. So you can see here, once you can expand a double bracket, guys, it's just about expanding the other bracket with that double bracket, and you've got it. Beautiful. Absolutely fantastic. So let's do another example, but this time we've got some negatives involved. So I'm going to go ahead, expand and simplify, take our first 2 pairs, so it's x minus 2 and x minus 3. So pay attention to your signs. X times x gives us x squared. X times minus 3 gives us minus 3x. Minus 2 times x gives us minus 2x. And a negative times a negative, remember, that gives a positive. So 2 times 3 is 6. We then simplify our b term. So I've got x squared. Minus 3 minus 2 is minus 5. So we've got a variable x. So it's minus 2. And minus 3 gives me minus 5x here, plus 6. Beautiful. Now I need to use this quadratic to multiply the other single bracket. Writing my single bracket first, x minus 4. I'm going to use that to expand the quadratic here. So I'm going to do x times by x squared, which is x cubed. Then x times minus 5x is minus 5x squared. X times by positive 6 is positive 6x. Finish using x, going on to the minus 4. So minus 4 times x squared is minus 4x squared. Minus 4 times minus 5x, 2 negatives gives a positive, so that's positive 20x. And minus 4 times positive 6 is minus 24. Now that I've multiplied them all, we're now going to simplify. I know my x cubed remains the same. Now let's do our squares. So I've got minus 5x squared and minus 4x squared gets me minus 9x squared. Now I need to do my x terms, 2 lines under, so positive 6, positive 20. That gives me positive 26, and the term is x, and my constant here is minus 24. Again, check for my 4 parts: a cube, a square, an x, and a constant. Absolutely brilliant. So guys, we move on to our next question. The next question asks to show that 3x squared plus x plus 1, 3x minus 1 and 3x plus 3 can be written in the form ax cubed plus bx squared plus cx plus d, where a, b, c, and d are all integers for 3 marks. Now, if you've watched the video that I've done on difference of 2 squares, you would find that this question can be done in a very simple way if we understand the difference of 2 squares. But for the purpose of this particular video, I'm just going to work it out, but you can watch this video here on the difference of 2 squares, and you would have known how to work out the first part without going all the way through expanding the 2 brackets. Beautiful. So let's start by doing 3x plus 1 and 3x minus 1. So 3x times by 3x is 9x squared. 3x times minus 1 is minus 3x. Positive 1 times 3x is 3x, positive 3x. And a negative 1 times a positive 1, still a negative 1. So if you notice here, the middle terms will cancel out because one of them is a negative and one is a positive, but they are of the same magnitude. When that happens, that cancels out to 0. So there is no b term in this one. So we just got a minus 1. And that now is called the difference of 2 squares. Absolutely brilliant. So now I'm going to take this answer and I'm going to use it to multiply the other bracket. So let's go. I've got 2x for the next bracket, add 3. So 9x squared times by 2x. So 9 times 2 is 18. X squared times x is x cubed. Then I need to do 9x squared times by 3. 3 times 9 is 27. So that's 27x squared. Then minus 1 times by 2, x is minus 2x. And minus 1 times by 3 is minus 3. So let's go simplify. So I've got 18x cubed, nothing to add to that. Then I also have my 27x squared. Guys, you see the result of this one? Nothing to group here. Everything stands by itself. So the answer is simply 18x cubed plus 27x squared minus 2x minus 3. And that's because the difference of 2 squares was involved in this example. Now guys, here is a question I would like you to try. So you're going to, it says find and simplify expressions for the volume of a cuboid with side lengths 2x plus 1, 5 plus x centimeters, and 4x minus 3 centimeters. So it asks you to find the volume. So this is an interleaving question, but just to get some momentum going in the comments section, give me the answer in this, and whatever account gets me the right answer, I'll give you a shout out in the next video. So I won't give the answer to this question here, just going to ask you to do it and put the answer there. So that means it's time for our key takeaways. So first thing we talked about, when expanding triple brackets, the result, once the variables are the same, the result is called a cubic expression. Now, a cubic expression, we talked about the largest exponent or power has to be a 3. Now, we also looked at the 4 parts. There are 4 parts: a cubic part, so highest power 3, then there is a square part, then there is a term of x, which means that the power is 1, and then there is a constant term. Now to expand 2 brackets, So when we're expanding 3 brackets, we need to expand the first 2, which is going to give us a quadratic expression. We then use the quadratic expression to expand the 3rd bracket, which then gives us the result of a cubic expression. And then by collecting our like terms, which is most likely to be the b term and the x squared term, we will now have simplified our cubic expression. Absolutely brilliant. So guys, the next video is going to be about identities, and even though it's identities and solving and equating them, it is very important that we understand how to expand bracket, because that will now be integrated back into it. Now, all these goodies here we cannot keep to ourselves, guys. We've got to share. We've got to hit the notification bell so we know when the other videos are uploaded. We've got to tell somebody else so they benefit from this beautiful information as well. So like, share, hit the notification bell and comment. I'm looking forward to your answer. Thank you guys so much for watching.